Hey, welcome back to the Gilbertson Aero Factory. Today is Friday the 7th of February, 2025. Safe bet that the primer that I put inside these aileron push tubes has had plenty of time to cure. So what I'm going to do today is get to work on getting these threaded rod ends inserted and then properly secured into both of these aileron push tubes, which have been precisely measured and cut to 23 and I forget, 13/16, I think. Anyways, that's probably enough of the introduction. There's some maybe kind of interesting stuff that happens or that will be happening with this stuff today, but I'll save that description for when we get into actually doing the work. So let's build an airplane. Okay, I'm happy to be back in the shop, but I'm not entirely happy with the results of how today went. So to find out about that, you're going to have to stick around. As I said, today I'm working on the aileron push tubes. These are the ones that run from the mid of the main spar aft, so they kind of run in the direction of travel off the bell crank, and they are the ones that connect directly to the aileron horns or whatever you call them, and make them flap, make them go up and down. And the challenge that people often have with these tubes is has to do with mounting these threaded rod ends, attaching them, like inserting them and riveting them into the tube. And it seems like, well, it's not easy. Let's put it that way. So in a minute here, I'll give you a better explanation of what I'm doing with these things. But one thing that deserves some explanation is that this is a really tight fit. These rod ends are, I want to say, the outside diameter that inserts into the tube is a 1/2 inch, and the inside diameter of that tube is a 1/2 inch, and so something's got to give. So you see me doing quite a bit of back and forth with Dremel and trying to find a way to get these things inserted without messing up the material. I mean, the tubes are 4130 chromoly steel, and the threaded rod ends, those are also steel. So I suppose I can't do too much damage, but I don't want to, if I'm sanding away to try to make them fit, I'm trying not to sand away all on one piece. So evenly distribute the amount of sanding between the inside of the tube and and the exterior of the rod end. And you might see me with that green deep reach socket. Basically, with the idea of it being, maybe a press fit was a socket will fit cleanly over the top of that thing, and then you can tap it with a rubber mallet or a dead blow and see if it'll move. But I ultimately decided against that and just get it to fit a little bit better, more snugly. But coming up here, I'll give you a sit down, better look at it. Okay, now's a good time, I suppose, to explain what I've been doing here with these threaded rod ends and the tubes, and trying to make sure that everything is going to work. I said before that I was thinking about welding this instead of riveting it. I sought some advice from experienced people, and welding is not a good idea. Even though it says it's an option, the wall of this tube is only 35 thousandths, and it'd be really easy to blow through. And riveting it is not as difficult as maybe it has been made out to be. So not saying that it's not difficult, but there are tricks, and one of the tricks is this right here. One of the viewers sent me a message and said that one of the things that he knew about this was that a problem that some people have when they're riveting it is not necessarily the rivet setting poorly, like it folding over on the top, but that in the inside, I should have shown you before, these are empty rod ends that the rivet will fold inside there. And so what some people have done, and what I've chosen to do, is to fill that with epoxy that can be drilled through. So then the path that the rivet's traveling through when you're going to set it is secure all the way around. So what I decided to use is steel stick epoxy. It's a steel reinforced epoxy putty. Not because I feel like it needs steel, because the only thing I'm trying to do is create a good channel for the rivet to pass through, but because within an hour this stuff cures completely and then you're able to drill it. So that's what I did there, waiting for that to finish up, and it's probably been close to an hour already, so I can. So the next thing that I was doing was just trying to get these things fitted into the tube. It's a really, really tight fit. And then I primed it. So I've been working with little bits of sandpaper, and then I've gone to the Dremel to hone this out a little bit, but I don't want to go too aggressively against that wall. So then I went to Scotch-Brite and sandpaper on the barrel end here to bring that down by, you know, 1/1000th of a thousandth. And ultimately, I'm able to get the fit here. Now, the most important thing is making sure that this fit, or that this rod end extends 5/8 of an inch down, and we have to make sure that there's the correct edge distance for these rivets. The correct edge distance is that these rivets, these AN 470 rivets, need to be 1/4 of an inch from the edge of the material. So you can see there's not a lot of room there to squeeze two in, but these two rivets are going in they're on different planes, so they don't need edge distance from each other, but they do need to miss each other. So those are the 2 points there, and how I got that was I printed a drill guide. So I went in Fusion 360 and I designed a drill guide. I started out with a sort of a sample iteration to make sure, I wanted to make sure that these two rivets, when they went through, would actually miss each other, and you can see that they will. So once I was happy with the dimensions here, that this would fit over the tube, and that the rivets would miss each other, and that the dimensions were right, that they would land in the correct spot, because it happens sometimes that once people get this inserted in here and they drill for that first rivet, they'll just end up notching this out. They won't be far enough up the thing. So then what I have is a drill guide that I can, jam nuts not necessary, but it just helps keep the rod end drawn up. So one piece. So then later when we get to drilling it in the drill press, we will be able to put this in the drill vise and drill exactly where I want to, turn it 90 degrees, drill exactly where I want to. There's enough room there where I can still go through one side, turn it 90 degrees, have that side I'm still locked in the vise back here, and go through and drill it. So that's why I made the length that I did. I made it as long as I did so that I didn't have to worry about this thing drooping in the drill vise. I should be able to lock it down and keep everything moving in a straight line. So that's everything about that. And we're back. So I did successfully get all those in there, using mostly sandpaper and a little sanding drum thingy on the Dremel. And I really kind of took my time with it. I didn't want to just go crazy and then find out that I have a loose fit. So I did get all 4 of them inserted nice and snug without beating the hell out of them. And I probably spent too much time showing you that on here. So maybe we can talk for a moment about the drill guide thingy, the idea. The portion of that threaded rod end that sticks inside the tube is 5/8 of an inch. And the minimum edge distance for a -4 universal head rivet is 1/4 inch. So if the top rivet has to be 1/4 inch from the end of the tube, and the bottom rivet has to be at least 1/4 inch from the end of the threaded rod end that's inserted in there, that's 1/2 of the 5/8 that you have, or 1/2 of an inch, and you only have 5/8 inch total. So in other words, you're using up 4/8 of the 5/8 just to get those two in from their respective edges far enough, if that makes sense. So that's the minimum edge distance is the distance from the center of the hole to the edge. So blah, 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 blah. Let me just say that the two rivets miss each other by 0.12 by 1/8 of an inch, or rather a 1/16 is the clearance between the two rivets when they past each other inside of that thing. Anyways, I hope that makes sense. Let's see. Yeah, got them all put in. Putting tool. It seems like I'm always putting tools away, or I should always be putting tools away. So we'll get into the actual drilling and testing the drill guide that I printed. So yeah, I did pick up a 3D printer. It turns out that there are models of 3D printer that it's just much less expensive than I had anticipated for something that is pretty freaking easy to operate. The hardest part of this was not the printing part, but was designing coming up with the design for this drill guide. And I can tell you that it worked brilliantly. No problem drilling perfect holes. You can see as it goes in, you can see the steel, and then you can see the lighter colored stuff. That's that steel putty, and then the steel again as it goes through. So what I do, because I know it's going kind of quickly here, I'll drill one hole, and then when I move to the other hole, I'll pin the other holes just to make sure that the material doesn't rotate. But it's such a snug fit, it probably won't. But anyways, that's why I pin it. You can see that I just put the little pick through there to make sure that the new hole is definitely going to still be 90 degrees away from or out of phase from the other one. So this worked out pretty well. I think here in a second I'll slow it down a little bit, still not down to a 1-to-1 or 100%, because that's just too slow. This work session was 4 hours. Obviously 4 hours is too long for just drilling a few holes, but you know me. Yeah, so here it gets a little bit slower so you can see how it went. I do really like this. I say my new drill press. I've had it for almost a year. But the laser thing on it, there may be a way that you can really calibrate it and get it super close, but it's close enough. The whole idea is, for me, with the laser is not like, oh, I can just put the crosshairs on it and jam that drill bit down. No, it just helps to get everything closer to lined up. There's less fussing around. You have a better idea where it is. But yeah, this drill press from Harbor Freight, of course, because it's me. I'd been wanting it for a long time, and then it went on like a unbelievable sale. So for like maybe more than 50% off when I bought it. So it was a worthwhile purchase. And then that vise that I'm using is, I think I got it at Northern Tool or something like that. And it's okay. It's not great. It's not super precise, but it gets it done, more or less. Okay, so there's just nothing happening on this camera right now, is there? Oh yeah, here we go. So what happens next? Now just comes the easy business. Now that we have perfect holes drilled and everything is square and the edge distance is perfect, now just comes the easy business of squeezing rivets.
And I've been told that the rivet call out is super long, longer than it should be. Here's what I learned. The rivet call out is for a dash 12 rivet. That is long. And when you measure the exposed tail or exposed shank of that rivet with the rivet gauge, it's clearly too long. If you put a dash 11 rivet in there, it is perfect. So the first thing that I did was I'm going to use the dash 11 rivet. And for some reason, and I guess it has to have to do with the fact that you are riveting on both sides on a curved surface. But when I riveted with that, when I squeezed that dash 11 rivet, it set no problem. A very nice shop head, except it was under squeezed. I can't really wrap my head around it. It's by definition it's the perfect length, but when you squeeze it, it comes out the proper height, but not the right diameter of the squeeze. So it is not properly squeezed. So then, well, I guess we got to take a 12 and try to shave a 12 down, and everything else I tried after that with a 12 or a 12, like 11 and a half shaved down, they all kind of, they fold. It's not like you're used to other times when you've had this experience. Again, because you're working with that round tube, something about it will start to squeeze and then it will like twist out, and it was not good. So I got to do my recurrent training in drilling out rivets again. Here's what ended up happening. As it turned out, I had the correct size CherryMax rivets, the perfect size CherryMax rivets for those holes. I measured them with my brand new CherryMax rivet gauge, and it came out perfect. But I have 5 of those because some of you may recall that I said that when I went to Vans, I got basically 5 of every size of cherry rivet that they had. I need 8. I had 5. So I did one of the torque tubes or push rods with CherryMax rivets, and the other one I just drilled out all the rivets, and then right before I put the lights out, I just took one more attempt to see if I was really careful. I folded around different things, different ideas, back riveting, whatever, came back to it, and decided save it for another day. Maybe just order some more of those CherryMax rivets and get on with your life. Get on with my life, rather. In fact, I'll show you right here. Here's how those turned out. So my first experience with the old CherryMax. Looks like maybe on one of them, the little locking thing was still on the top. I'll have to go back and look at that again. Yeah, a different experience with the CherryMax, but the pneumatic rivet puller did a good job. I did follow Van's little video on how to prep them with some WD-40. That's worth checking out. If you look at Van's YouTube page and look for CherryMax, they'll show you how to do it. And anyways, that's today.